Hey, gentlemen. I'm sorry I was muted. I got an email to cover 5, 6, 8, 9, and 15. So I know I'm covering those. But if there's others that you had a question on as well, I will make sure I get those. Is there one before number 5 that you would like for me to do?
3 and 4, please.
3 and 4. Okay. I'm looking for two factors that equal 56 when I multiply them, that when I add them, they are 18. So I want to list the factors of 56. So that's going to be 28 and 2, 56 and 1, and 7 and 8, 14 and 4. I can't think of any more. But 56 and 1 is 57, 28 and 2 is 30, 7 and 8 is 15, and 14 and 4 is 18. So those are my two factors. You just have to make sure you get all of the factors. And a lot of times you might have to do a factor tree if it's not right in your face, like, oh, that's so obvious kind of thing. You might actually have to do a factor tree for it. But you just want to list all those factors out. All right, number 4. I want all of the factors that multiply together to give you 4, that when you add them give you 4. Well, the factors of 4 are 4 and 1 and 2 and 2. So that's going to be W plus 2, W plus 2, which can also be written like this, W plus 2 squared, because there's 2 of them. So those are squared. For number 5,
I have a quick question.
What?
When's the quiz?
Friday.
Okay, thank you.
Uh-huh. Okay, so on number 5, I'm looking for two factors that multiply together to give me 8, that when I add them give me 9. So what are the factors of 8? 8 and 1, 4 and 2. I think that's it. So 8 plus 1 is 9. So that's my answer there. So 8 plus 8, or 8y plus 8. I'm awake, I promise.
I have another question about the quiz.
Yes.
Is it okay if I bring one note card with a couple notes on it? Because I've done that on the previous quizzes and you've been fine with it. Please?
Yeah, I think so. I'll pray about it and I'll confirm for all the classes on Wednesday.
Okay, so I can, right?
As of right now, I would be okay with that, just to try to keep you guys straight. I don't know what you would. Well, I guess I do know. Just like little notes to yourself, a note card. Okay.
Thank you.
Yeah, because I think on the last quiz too, on 9th grade took it, 8th grade didn't. They were allowed to even use their notes from class. Okay, for number 6, I'm looking for two factors that multiply together to give me 66, that when I add them give me 17. So what are the factors of 66? They are 66 and 1, 33 and 2, 11 and 6, 22 and 3. But I can see
It's
that 11 and 6 add up to be 17. All right. Do you all want me to do number 7 or just skip to number 8?
Can you do
You
7?
could try
please?
number 7.
Okay. I'm looking for two factors that when multiplied give me a positive 8, but when I combine them give me a negative 6. So that tells me right there that both of my terms have to be negative because two negatives make a positive. And that's the only thing that could give me a negative in this middle part right here. If this is positive and this is negative, that tells me both of my factors have to be negative. So what are the factors of 8? So if I multiplied -4 and -2, that would give me a positive 8. But if I added them, it would give me a -6. -1 and -8 also would give me a positive 8, but that would give me a -9 as my middle term. So that's why that one wouldn't work. So it's y minus 4, y minus 2.
But does it matter if I did y minus 2 and then y minus 4? Because it's
No, it does.
multiplication.
The order of the actual terms does not matter because these are being multiplied to each other. And
Okay.
multiplication is a commutative and associative property. So the order doesn't matter on that. So if you did y minus 2, y minus 4, you're absolutely fine. Once again, on number 8, I have a positive here for the last term, but a negative for the middle term. So that tells me both of my factors need to be negative. So what two factors multiply together to give me a positive 28 that give me a negative 11? So I have 14 and 2, but that would give me a negative 16. I have -7 and -4. Well, that would give me a negative 11, and it would give me a positive 28. Okay, number 9. Number 9, there's a negative at the end and a negative in the middle. So that tells me one of my factors has to be positive and one has to be negative because a negative times a positive is negative. And so then I'm going to find the difference and give the sign of the higher term. So what are the factors of 90? 90 and 1. Well, and the bigger one I know has to be negative because that's this term right here. Well, that would give me a negative 89. So that one doesn't work. -45 and 2. That would give me a negative 43. So that doesn't work. 10 and 9. -10 plus a positive 9 gives me a -1. And that's this term right here. Because when there's no coefficient, the understood coefficient is 1. So my factors are n minus 10, n plus 9. So I'm not bringing my soccer stuff. Okay. I'm not going to the game because if I can't play, then I don't care. Then I'm assuming they don't want me to just sit there. They don't want me to do school. Okay. All right. Any questions about 10, 11, 12, 13, or 14?
Can you do 13?
Yes, I can do 13. So I have a negative here, which tells me one of my factors has to be negative and one has to be positive. So I'm thinking of all the factors of 6, which are 6 and 1, 3 and 2. And with this being negative here, with this being negative here and this positive here, you know the bigger of the two has to be positive. So if this is a +6 and this is a -1, hold on just one second. Sorry about that. Okay. I'm going to go back and kind of start at the beginning since I had to cut off. Anyway, the -6 says that one factor is going to be positive, one's going to be negative. The positive here tells me the bigger of the two is going to be positive. So I'm looking for all the factors of 6, which are 6 and 1, 3 and 2. And I've already stated that the bigger of the two is going to have to be positive because in order for something to be multiplied and give you a negative times a positive is a negative. And when you combine the terms, you combine them and give the sign of you find the difference and give the sign of the higher. So if I add a +6 and a -1, that would give me a +5. So my factors are m + 6, m - 1. All right. Anybody need me to do 14 before I move to 15?
No, I just did number 14, but I couldn't think of all the factors of 56, so I had to Google it. But what if you are on a test or something and you don't know all the factors of like a big number?
If you really, in all honesty, then you should do a factor tree. And so this would be 28 and 2, 14, 2, 7, 2, which then you would look 2, 4, 2 times 2 is 4 times 2 is 8. So 8 and 7. You would just have to look at all these different factors and try to figure out what the middle is. You would not be able to Google it.
Okay, thank you.
Uh-huh.
I forgot about the factor tree until you reminded me of it. Thank you.
Oh, okay. No problem. But so that's what you would do. And then you would just try to look at all the different factors and make different combinations till you got that middle section. But this is positive and this is negative. So that tells me both factors have to be negative. So I'm looking right now and thinking 7 and then my 8 over here is going to give me the 15. All right, now number 15. I'm looking for factors that multiply together to give me a -39 that when I combine them, give me a negative 10. So that tells me one's going to be positive and one's going to be negative. So I'm thinking of all the factors of 39. Once again, if you don't know what those factors are, you could always do a factor tree. And then 13 and 3 are both prime. And I already said one has to be negative, one has to be positive. So a negative 13 combined with a positive 3 would definitely give me a negative 10. So you've got x minus 13, x plus 3. Any questions on the remainder specifically?
Wait a minute. On number 13, you wrote down positive 6 and negative 1. Shouldn't they both be negative? Wait, no, that's not right. Never mind.
No.
I was confused with number 18 because on number 18, they're both negative, I think.
You're absolutely correct. When this symbol, good job, this symbol here, when this is a positive and this is a negative, then both have to be negative. Because a negative times a negative gives me a positive. But when I combine two negatives, I get deeper in the hole. Are there any questions before then?
I have one question.
Yes.
Isn't 51 prime?
51. No, ma'am. Because 51, 5 and 1 add up to be 6. So that means it's divisible by 3.
Okay.
That's the divisibility test for a prime number. So let's take a look at it. If we know it's divisible by 3, 3 goes into it. Let's see, 1. So 17. So 17 times 3.
Okay, thank you.
No problem. And then there's your factors right there. Yeah, the divisibility tests, I have them hanging in my room. You may not have ever noticed the poster. It's behind my desk. But that's always really good for factoring. The divisibility test for 2 obviously is that the numbers are even. But the divisibility test for 3 is if the digits in the number add up to something that's divisible by 3, then you know it's divisible by 3. Like 39, back up here where we saw it was divisible by 3, 3 plus 9 is 12. And you know 12 is divisible by 3. We did kind of the same thing. And 18, 1 plus 8 is 9, and 9 is divisible by 3. So that's the divisibility test for 3. And another thing, if a number is divisible by 3 and divisible by 2, it's also divisible by 6. So like number 18, it's divisible by 2 because it's even, divisible by 3 because the digits add up to be 9. So that means it's divisible by 6. And we know that 6 times 3 is 18. So just the divisibility tests are always really helpful in factoring. Because trying to figure out what things are and then doing your factor tree and stuff like that. Okay, how'd y'all do on the bottom part?
Scroll up for a sec. I didn't see 15. So sorry.
Oh, no problem.
Okay, thanks.
How'd y'all do on the bottom part? Finding the GCF.
Okay, I'm good. Thanks.
Any questions on the bottom part? Anyone you want?
Confused me.
Okay. All right, so the first thing that you need to do is take out the greatest common factor. So what you're looking for is something that each term can go into, like something that each term has in common. So like in number 19, you know that each term is divisible by 2 first, right? Because they're all even. And that's the divisibility rule for 2. So let's take a 2 out of each term. So if I take a 2 out of this term, that gives me k squared. If I take a 2 out of this term, that's 4k. And if I divide 90 by 2, I get 45. So now I've got everything. This term right here is exactly like everything that we had above. It's just a regular trinomial ready to be factored in coefficient of 1. So what are the 2 factors of negative 45 that when combined would give me a negative 4? That tells me one is going to be positive and one is going to be negative. And the bigger one is going to be negative because this is negative right here. And whenever you combine a positive and negative, you find the difference and give the sign of the higher one. So let's see, 15 and 3. That would give me a negative 12, negative 9, and a positive 5 would give me negative 4. So just like I was doing up above, k minus 9, k plus 5. On number 20, it doesn't look like there's a number that each one has in common, but it has a letter in common. So if I take the letter x out or divide each one of these by an x, if I do x cubed divided by x, that would leave me an x squared. And if I divide 2x squared by x, I would be left with 2x. And if I divide a negative 48x by x, I would be left with a negative 48. So I'm looking for 2 factors. One's going to be negative, one's going to be positive because I have a negative 48. And the bigger one is going to be positive because this is positive, the leading sign or the sign before the middle thingy, as I said in class yesterday. So what are some of the factors of 48?
2 and 24.
Good job.
4 and 12.
4 and 12. Somebody said 6 and 8. Good job. And if we do 6 and 8, if we do a negative 6 and a positive 8, we would definitely get what we're looking for, I think.
And what is it exactly what we're looking for?
In which part, baby?
Just overall, like with the GCF, like what's our main goal?
For the GCF?
Yes, ma'am.
That's kind of back to what we were doing, what we began last Wednesday when you were factoring out the GCF.
Mm-hmm.
You're looking for the biggest term that goes into all of them.
Okay.
And factoring it out. In this particular lesson, what you know you're going to end up with, because you're continuing to practice that, is you're going to be ending more than likely with a trinomial that can be factored.
Okay.
Does that help?
Yes, ma'am.
Okay. So like on number 21, you can see that each one is even, so you know 2's going to go in it. But since this leading coefficient is a 4, and you've pretty much been working with a leading coefficient that was 1, I would suggest that possibly 4 is going to be, it's going to be able to take a 4 out of each one. Does that make sense?
Yes, ma'am.
So if I take a 4 out of each one of those, I would be left with w squared. And if I take a 52 and divide it by 4, I'm going to get 13w. And this last one here is going to give me a negative 30.
That's what I got.
Okay, so I'm looking for two things that multiply together to give me negative 30, but when I combine them, give me a negative 13. And so right away, the first thing that came to my head is, oh, that would be 10 and 3 because 10 plus 3 is 13. But don't forget, one of them has to be positive, one of them has to be negative. So that wouldn't work because that would be in our bigger one is going to have to be negative. So that would be negative 10 and 3, and that technically gives me a negative 7. So that one doesn't work. So I need to kind of keep looking. 6 and 5 definitely doesn't work because that would give me a negative 1. How about negative 15 and 2? That definitely works. So sometimes it can be a little tricky in the fact that, you know, our brain is thinking, oh, 10 and 3 is 30. So you got to be really, really careful. And remember your rules of, oh, that's negative. This is negative right here. Let me do it in a different color. That's negative. This is negative. So that means one's going to be negative, one's going to be positive. Did that make sense to you guys? All right, number 22. What do you think I can factor out of this one?
A 2.
Yes, good job. So I would take a 2 out, and that's going to leave me x squared plus 5x plus 4. So I'm looking for two factors that multiply together to give me a positive 4 and a positive 5. So that's going to be, anybody know? What are the factors of 4?
1 and 4.
Good job. 1 and 4. Good job. All right. What do you think we're going to be able to factor out of number 23?
3.
Good job. So if I factor out a 3 out of each term, I'm going to be left with y squared plus, and 3 goes into 24y. I'd be left with 8y. 3 into 14 is, into 48 is 16, sorry. So now I'm looking for two factors that of 16 that when I add them would give me an 8y. Anybody know what those are?
8 and 1.
8 and 1 give me 8. There's 8 and 2, but that would give me 10 here. 8 and 2 is 16. What are some other factors? Yes, 4 and 4 multiply together to give you 16. And you could actually write this like this if you wanted to also. But 4 and 4 multiply to give you 16, but add to give you 8. All right, what do you think you can factor out of number 24? There's a number and a letter. Yes, 5.
M.
5m. Good job. So if I factor out a 5m out of here, I would be left with an m squared. 5m here, I'd be left with a 6m. And 5m here, I'm going to be left with a negative 7. So I'm looking for two factors that multiply together to give me a negative 7 that when I combine them, give me a positive 6. That tells me one of the factors is going to be negative and one of the factors is going to be positive. The bigger one is going to be positive because my middle number is positive. So positive 7, negative 1. Is this starting to make any more sense to you guys?
Yes, ma'am.
Yes.
Okay, good. Any other questions?
No, I think that's it. Thank you.
You're welcome. Y'all have a blessed day.
You too.